Hello.
Hello?
Yeah, can you hear me?
Yeah.
Okay, so we'll continue with our discussion of problems from these three papers.
Yes.
Okay, okay, so tell me which ones you have tried. What is the situation so far?
I did the AMC 2022 10A and 10B.
Hmm.
Yeah.
Yeah,
But I need help on usually the last few problems.
right.
Yeah.
So which ones? Tell me.
So for 2022 10A, I need help on problem 17. I kind of got stuck while I was doing it.
Okay, so the question, which is the number of three-digit positive integers.
Yeah.
Okay, so let's look at that one. How many three-digit positive integers are there whose non-zero digits ABC? Three-digit positive integers are there, non-zero digits ABC, satisfy the condition. They are saying 0 point ABC repeating is equal to 1 by 3, 0 point A repeating, 0 point B repeating, 0 point A repeating plus 0 point B repeating plus 0 point C repeating, right?
Yeah.
Okay, so we have to first of all figure out what is the fraction that represents these. So if you think about it, let's think about what is the fraction that represents this number. So basically this is like 0 point ABC, ABC and so on, right? So if you call that as X, we can multiply it by 1000 and you'll get ABC dot ABC, ABC and so on.
Yeah.
So if you subtract one time X from here, you will end up with simply ABC is equal to
Right.
999X.
Yeah.
So you'll get X is equal to ABC by 999.
Yes.
But this ABC is actually a number. It's not product of ABC, right?
Yeah, it's the number.
So basically that means actually it is 100A plus 10B plus C.
Yeah.
So what we are writing is this thing can be written as 100A plus 10B plus C divided by 999, right?
Yeah.
That's the fraction representation of this. And then 1 by 3, and this is A repeating. Obviously this will be just A by 9, I think.
Yeah.
A by 9 because you will say 10 times X will become A dot A repeating. So you will get 9A is equal to A, right? 9X is equal to A.
Yeah.
So this is A by 9, B by 9, C by 9 here, right?
Right. Yes.
So we can take a 9 common and cancel. 111 will come and then we simplify it out. We get 300A plus 30B plus 3C is equal to 111A plus 111B plus 111C, right?
Yeah.
I hope I'm not making a mistake here. Cancel the 9, right? And then we multiply it and then we will simplify this. So you will get a 189A is equal to 81B plus 108C, right? This is what we are getting. We can cancel
Yeah.
9 from here. So you get a 21 here.
hmm
You get a 9 here, you get a 12 here. And basically we can
Yeah.
cancel 3 again. So we'll get a 7A is equal to 3B plus 4C.
Yeah. I got that. Yeah.
Okay, So once we have gotten 7a is equal to 3b plus 4c, now we have to think of which digits, which positive integers will we be able to put here for ABC. Obviously, we know that the digits are all non-zero, so ABC are between 1 and 9, right?
Yeah.
And you have to find all possible three-digit numbers. So you need to find all numbers like this, where obviously 1 is less than A, less than equal to 9, and that holds for B and C also, right? But we have
Right.
to satisfy this condition at all times, right?
Yeah.
Okay, so now let's think about it, what we can see here. So how can we figure this out? So here you have to use a little bit of number theory that we'll learn soon. So we'll learn in our number theory classes and all. It's about congruence. So we'll say that left hand side is clearly divisible by 7, right?
Right. Yeah.
So when you do modulo 7, left hand side is 0 modulo 7.
Yes.
That means 3b plus 4c is also 0 mod 7, right?
Yeah.
Now you can say from here that 3b and 4c, if they're adding up to 0 mod 7, then b and c, if you think about it, 3 and 4 will not be contributing anything to modulo 7. They don't
Right.
even have a common factor other than 1, right?
Yeah.
So what we can say is b is congruent to c here, mod 7. Because otherwise, what will happen? Here we are getting 3b is congruent to minus 4c, my mod 7, right?
Yes.
The only way this can happen is if, since 3 and 4 have nothing in common, we don't have to worry about that. B and C have to be congruent to each other mod 7, then only this can happen.
Right. Yeah.
Think about any numbers. If you have 1 and 2, for example, you will never be able to get a 0 mod 7.
Yeah.
Both have to leave the same remainder with 7. For example, you can get a 0 mod 7 by making, for example, 1 and 1, right? See?
Yeah.
And what you have, what happens if you do 2 and 2? You will see 6 plus 8, 14 is coming. Right? Again, 0 mod 7.
Right. Yeah.
Do you understand why it is coming like that?
Yes.
Both the numbers have to leave the same remainder when divided by 7, because when they add up, they are getting 0 mod 7. So,
Yeah.
and 3 and 4 have no common factors, no common factors with each other. So, 3b and 4c are basically congruent to each other, which means b and c are congruent to each other, right?
Yeah.
So they basically, if B and C are modulo 7 equal, then that means you can be 1 mod 7, 2 mod 7, up to 6 mod 7, right? Like that.
Yes.
Actually, all the cases, B and C could be anything from 1 to 9 as long as they're equal, right? This will give us 9 cases. In every situation, if B and C are equal, automatically there will be an A that will be there for them, right?
Yes. Right.
Why? Because see, if you put B and C are equal, then you automatically get 7C here, right? Then automatically everything becomes A. A is also C.
Yeah.
All the numbers become same then, right?
Hmm.
Do you understand what I'm saying?
Yes.
So you're getting 9 numbers for sure, which are 111, 222, numbers like that, right?
Yeah. Right.
Now you have to think of any other cases that are there. So how can we still get 7A is equal to 3B plus 4C? We can do that if we say that, see, the remainders of 7 are from 1 to 6, right? But
Yes.
you could also have, or 0 to 6. These are the remainders that come when you do 7. But you could also have B is 8 and C is 1.
Yeah.
Because technically 8 is also 1 mod 7. Like they don't have to be equal to be congruent, right?
Yeah. Right.
So B is 8, C is 1 is possible. The opposite is also possible. B is 1, C is 8, right?
Yeah.
And similarly, B is 9, C is 2 is possible. And the opposite is also possible. B is 2, C is 9, right?
Yeah.
That still keeps them congruent to each other, but this gives us different values of A, I think. So let's check the values of A. So when B is 8, you get 24 plus 4, 28. A is 4 here. So you get 481 here, right?
Yes.
When B is 1, C is 8, you will get 3 plus 32, 35. A is 5, right? 5,
Right.
1, 8. And when B is 9, C is 2, you get 27 plus 8, 35. Again, you get a 5. So 5, 9, 2. And finally, when B is 2, you get 6 here and 4 into 9, 36 here. 42. So A is 6. 6, 2, 9, right?
Yeah.
So these four numbers are also there, which satisfy the B and C being congruent condition, right?
Right. Yeah.
But they are not the numbers where B and C have to be equal. The equality case was happening when the remainders were like equality case is obviously there 1 through 9. All of them are equal, right?
Right. Yeah.
So 9 numbers are there, obviously 1, 1, 1, 2, 2, 2, and so on, right?
Right.
But apart from that, there are these four numbers also. So the answer will be 13.
Yes.
Do you understand what we have done?
Yes.
Okay. What is the next one?
The next problem I had was 18.
Okay. Let TK be a transformation. TK be a transformation of the coordinate plane that first rotates the plane k degrees counterclockwise around the origin and then reflects the plane across the y-axis. Okay. What is the least positive integer n such that performing the sequence of transformations t1, t2, t3 till tn returns the point 1, 0 back to itself? Smallest integer n so that 1, 0 comes back to itself after all these transformations. Okay. So 1 degree rotation counterclockwise and then reflect the plane across the y-axis. That's the part we have to understand. First rotates the plane. It is transforming the coordinate plane itself, right?
Yes.
So basically, hmm, just think about what is happening here. Uh, so counterclockwise rotation is happening. You have to take the point 1, 0 and you have to bring it back to itself, right? If you do
Yes.
a 1 degree rotation, you would be somewhere like this, somewhere here, right? The
Yeah.
plane itself has rotated. So this angle is 1 degree
Yes.
on T1 and then reflect it about the y-axis. Reflect the whole plane about the y-axis. So you would end up somewhere here, right? right?
Right.
And then you again rotate it by 2 degrees now, right?
Yeah.
Correct.
Yes.
So 1 degree, now it will be 3 degrees total, and then reflect it about y-axis, so it will end up here, right?
Yeah.
Do you understand what I'm saying?
Yes, I understand.
So we have to think of what is going to happen as a result of all this. Uh, so one good way to do this would be to think of polar coordinates, because rotation and reflection is happening, so the distance from the origin will not change, right?
Right.
Like what I'm saying is, if you represent any point as r comma theta, right,
Yeah.
where theta was basically your angle with the positive x-axis,
Mm-hmm.
so then I don't want to keep track of all the angles in every step. I want to do a general process by which I can understand what is the pattern, right?
Right.
It will be difficult to keep track of T1, T2, T3 all the time.
Yeah.
So anytime I do a TK, I do a rotation of my point by k degrees, right? So my
Yes.
point r theta goes to r by counterclockwise. So it will become r theta plus k, right?
Right. Yeah.
And now I have to do a subsequent reflection. So if my
Yes.
point was somewhere here, reflection about y-axis will take it here, right?
Mm-hmm.
And if this angle was theta, now my new angle is basically pi minus theta. Do you understand what I'm
Right.
saying?
Yeah.
Because this, if it was a reflection about y-axis, this angle is also theta.
Right.
So
Yeah.
this whole angle is 180 minus theta, right?
Yes.
So basically, however, I'm not reflecting this, I'm reflecting this, right?
Right. Yeah.
R theta goes to r comma pi minus theta. So what
Yeah.
will this go to? R comma pi minus theta minus k, right?
Yes.
So this is what tk does. It takes r theta and it sends it to this point, right?
Mm-hmm. Yeah.
Correct. So now I just have to think about, if I do a sequence of operations T1, T2, and so on, how will I get back to my original thing, right?
Yes.
So, okay, so we have to figure out a pattern. Uh, so once Tk we have figured out what is Tk, what happens when I do Tk plus 1 on the Tk itself, right?
Yeah.
So this is the Tk point, which is r comma pi minus theta minus k, right?
Yeah.
On that, I'm going to apply this. But remember, now what will happen is r comma, when we did tk to this, what happened? Pi minus theta minus k, right?
Yes.
Now I'm doing tk plus 1. So it should be r comma pi minus, what angle am I doing it on? I'm doing it on this angle already, no?
Yes.
So it will be pi minus theta minus k minus k plus 1, right?
Yeah.
You understand what I'm saying?
Yes.
So notice this is pi gets cancelled. You get a plus theta plus k minus 1. So ending up with
Right.
r comma theta minus 1,
Right.
right?
Yeah.
So, okay. So if you start off with r theta, you'll go to after one operation you go here, and after another operation you go to r comma theta minus 1, right?
Yeah.
This is after uh we start off with what k value? We start off with t1, right? So
Yeah.
when we apply t2, that is what we end up with, r comma theta minus 1, right?
Right.
The value of k actually doesn't matter, no? See, you are ending up on r comma theta minus 1 regardless of whether you did tk or tk plus 1.
Right. Yeah.
The value of k doesn't seem to matter on. So basically it's a weird situation where if I apply t3 to this, then it will matter what will happen, no?
Yeah.
Because t3 to this would become r comma pi minus theta minus 1 minus 3, right?
Yes.
Do you understand? It is becoming pi minus theta plus minus theta plus 1 minus 3, so minus 2, right?
Yes.
But T4 will again bring it back to, I think, r comma theta minus 2. Just check that once. Because it will be, it takes this, every time this is the operation. So we apply it now to this angle, right?
Yeah.
So T4 you are doing, it will be pi minus theta minus 2 minus 4, right?
Right.
So this becomes theta plus 2 minus 4. So see, it is theta minus 2. Do you understand what I'm saying?
Yes.
So we are seeing that the even time when you're operating. So first time you do, okay, I'll just summarize what we have gotten so far. This is our starting point r theta. When you do T1, you go to r comma pi minus theta minus 1, right?
Right.
When you do T2, you go to r comma theta minus 1. When you do T3, you get to r comma pi minus theta minus 2.
Yeah.
T4 is r comma theta minus 2, right?
Yes.
So there is a nice pattern here, right?
Yeah.
And now you are starting out with 1 comma 0 degree, right?
Right.
So after T1, where are you? 1 comma pi minus 180 minus 0 minus 179 degrees, right?
Yeah.
After T2, you are at 1 comma theta minus 1. Theta is 0 degrees. So minus 1 degree, right?
Yes.
T3, you are at 1 comma 180 minus 0 minus 2. So 178 degree, right?
Right.
T4, you are at 1 comma theta minus 2. So minus 2 degrees, right?
Yes.
So it is obvious that you want to come back to 1 comma 0 again, right? And
Right.
T1 is sending you to 179 degrees, then 178, 177 like this, right?
Right.
179, 178, okay. And so basically T179, you can sort of predict will be 1 comma 1 degree. Can you see the
Yeah.
pattern,
Yes.
right?
Right.
And T180, notice the odd even number power, what is happening? T180, okay, so then what will happen when I do T180? It will be, I'm applying the normal operation to this, right? So
Yes.
it will become 1 comma 180 minus 1 minus 1, right?
Right.
Actually, It is just 1 second. I'm making a mistake here in the pattern. So T180 will send us to theta minus 90, right?
Right.
By the pattern.
Yeah.
D360 would have sent me to 1 comma theta minus 180.
Yes.
So T359 would have been the one before that would have been pi minus theta minus 1 comma pi minus theta minus 180, right?
Yeah.
Do you understand what I'm saying?
Yes.
This and this will cancel and it will be 1 comma 0 again, no? See?
Yep.
Because initial theta was 0. So this is 0, 1 comma 0, right? T359.
Yeah.
Do you understand what is the basic thing that is happening?
Yeah, I
After
understand.
that, you just have to keep repeating it and understand when you will get the 1 comma 0 again.
Yeah.
Answer is 359. So the point here is to understand how reflection across y-axis will work, how rotation works, and polar coordinates helps us to generalize it in an easier way.
Right.
Because polar coordinate automatically talks about angles and all and preserves the distance from the origin, right?
Yeah.
So it is ideally suited to think about rotations if you want to do polar coordinates.
Okay. Yeah.
Correct?
Yes.
Okay. What is the next one?
Problem 19.
Okay. Uh, right. The question is saying define ln as the least common multiple. One second. Ln is the least common multiple of all the integers from 1 to n inclusive of all integers 1 to n, including 1 and n.
Yeah.
It's like the LCM of all of these integers. There is a unique integer h such that 1 by, okay, 1 by 1 plus 1 by 2. Okay. There is a unique integer h such that 1 by 1 plus 1 by 2 plus 1 by 3 till 1 over 17 is equal to h by L17. So 1 over 17 is equal to h by L17. Okay. What is the remainder when h is divided by 17? So basically, remainder when 17 divides h. That is being asked. Okay. So we have to find h somehow. Knowing that what is L70. L70 is just the LCM of 1 to 17, right?
Right.
Okay. Uh, right. So let's try to find out L17 here. If we can find out L17, then it will be easier to simplify this then. Like technically, what are you have to do? To add the fraction, you need to write L17 here, no, somehow.
Right. Yeah.
Then only you can add the fractions ideally. But you can also add it by multiplying everything, but that will be much larger than L17. No?
Yes.
The least common multiple will be significantly smaller than the product of all of these numbers, right?
Right.
So the main idea here is if you can figure out the L17 value, then you can solve this question easily. Because then you can actually simply add the fractions and get h then, right?
Yes.
H is going to simply be the sum of the appropriate numerators here, correct?
Right. Yeah.
Okay, so think about it. How can we find the LCM of numbers from 1, 2, 3 till 17? What is the method when? So if you know the general method of finding LCM, you can easily find this LCM.
Like the prime factors, sort of.
Right. So if you had
Yeah.
only two numbers, how would you find the LCM?
You take like the prime factors of it and multiply.
So suppose they had number had prime factors 2, 3, 5 with some powers. Other number had prime factors 3, 7, 11. So what would you do in that case to get LCM?
2, 7, and 11, I'd take like the prime factorization of 2 is 2, the prime factorization, like take the common factors and then multiply. But since there are no common factors, the LCM would just be all of it multiplied.
No, what I'm saying is, suppose I had two numbers. One is 2 power x, 3 power y, 7 power z, and another number is 3 power p, 7 power q, 11 power r. How would I find LCM of a and b? Ah,
Oh, you'd
tell
see
me.
like the common like
It's not HCF, it's not GCD, it's LCM, right?
oh right,
It's
yeah.
lowest common multiple. Multiple means the power has to be big. No, number is bigger than these two numbers.
Yeah.
So how can we do LCM using the prime factorization?
You take the
Higher powers, right?
yeah, the higher powers.
We can't take the smallest powers. We have to take the biggest powers. And also,
Yes.
if the prime here is there, but it's not here, we still have to put that here, right?
Right.
If your LCM doesn't have 2 power x, then A can never divide it, right?
Right.
You understand what I'm saying?
Yes.
Here it will be 3 power, whichever is the bigger out of y and p. And then it will be 7 power, whichever is the max of q and z, right? And then it
Yes.
will be 11 power r because that is not present in the other one, right?
Right.
So the prime factorization tells you the way to find LCM. You have to always keep track of the higher powers, right?
Yes.
And also don't miss out on any prime factor because all prime factors of any number must be present in the LCM of those numbers. No?
Right.
Do
Yeah.
you understand what I'm saying?
Yes.
So what is L17? So notice that any prime number we can pick the highest power that appears, right?
Yes.
L17 is technically LCM of 1 to 17, correct?
Yeah.
So in that LCM of all of these numbers, we can write the prime factorization of each of them and take the higher powers when you do common stuff, right? So 1
Yes.
into 2 power. Notice 16 is 2 power 4. You can't have anything less than 2 power 4 here. Right?
Right. Yeah.
9 is 2 squares. So you can't have anything less than 9 because then
Mhm.
3 square has to be there at least, right?
Yes.
Then 5 has only one power, right?
Yeah.
5 square is 25, which is beyond the range.
Yes.
And finally, 7 has one power and 11 has one power.
Right.
Do you understand what I'm saying right now?
Yes.
13 has power 1, 17 has power 1. These are all the prime numbers, right?
Yeah.
Notice that this is actually 16. So it is 1 into 5 into 7 into 11, 13, and this was 16. Uh, 16. I'm just writing the numbers right now because I have to add the numerators, right?
Yeah.
11, 13, 16 is done. Only 17 was left, right?
Right.
16 has come because we did what? We said that uh, 2 power 4 is the highest power of 2. That must be present, right? Then.
Yeah.
Okay. So once we know the LCM, you can easily now find all the fractions, no? Now.
Yes.
Do you understand that the problem is totally doable now?
Yeah.
Because we know the fractions, you can always write on top those things, no? Other numbers.
Yeah. Right.
And then that becomes your h, and you have to do h modulo 17. So whatever number you get for h, you have to take remainder. So what I
Yeah.
would suggest is don't try to multiply all the numbers and add them. You don't need to do that, right?
Yeah.
Don't do that because that multiplication and addition will take a lot of time, right?
Right.
So what you should do is do modulo 7 on each of these and see what is left. Do you understand what I'm saying?
Yes.
So then this problem will become doable once you find the correct LCM. After that, you just have to add it. And when you add it, don't multiply and add everything and calculate the number finally here. Don't need to do that because you just have to do modulo 7, right?
Right. Yeah.
So each of the terms that comes on top, for example, it is 1 by 2 was the first term. Oh, 1 by 1 was the first term. 1 by 1 plus 1 by 2 and all. So obviously in 1 by 1, everything will come, right?
Yeah.
But everything coming is not bad because we can still see if everything comes, it is modulo 7 is 0.
Right.
Do you understand? Because it's
Yes.
divisible by 7. Similarly,
Yes.
what I'm saying is, we know this is 0 mod 7. Find out all the mod 7 of these, right?
Yeah.
You don't have to actually multiply it. You just have to see what is the modulo 7 that will come, right? Or what is the
Yes.
remainder that will come on doing division by 7. Once you have that, the question is over then.
Right.
Do you understand? You have to add up all of these remainders, and that will be your final thing,
Yeah.
right? So, do you understand? You can now finish off the problem yourself also.
Yes.
Okay, what else?
The next problem I needed help on was problem 22.
Okay. 22 is this card problem, right?
Yeah.
Right. Suppose the 13 cards, okay. Suppose 13 cards which are which are numbered 1 to 13 are arranged in a row. 1, 2 to 13 are in a row. And the task is to pick them up in numerically increasing order, working repeatedly from left to right. In the example below, cards 1 to 3 are placed on the first pass. 1, 2, 3 are placed on the first pass. And then working repeatedly from left to right. Okay, okay. 1, 2, 3 is picked up on the first pass, and 4 and 5 on the second pass, and 6 on the third pass. You have 7, 8, 9, 10 on the fourth pass. Okay, slightly confusing. The task is to pick up it numerically increasing order, working repeatedly from left. Okay, you have to only pick those numbers which are numerically increasing order from left to right, right?
Yeah.
So you can pick 1, 2, 3, 7, 8, 9, 10. You can pick also 6, 7, I'm guessing, right?
Yes.
Okay. 7, 8, 9, 10. For how many of the 13 possible orderings of the cards will the 13 cards be picked up in exactly 2 passes? For how many of the 13 factorial possible orderings will you pick up all the 13 cards in just 2 passes? Okay. Right. Hmm. For every card position, we can you have to pick everything in 2 passes. So every card position can be picked either in the first pass or in the second pass, right?
Yes.
So there are total of 2 part 13 ways to pick them, no? Or pick them either in the first pass or second pass, right? Give them 2 choices for each position, right?
Yes.
So there are 13 cards. So 2 into 2, 2 part 13 ways. 2, okay. So if all of the cards which are selected to be the first card that you book or that you pick up, I'm unsure of this right now. Not sure right now. Hmm. Okay, I'll try it out. Let's move on from this for now. I will have to think about it a little bit. Uh, did you also try 10B or something?
Yeah, I tried 10B.
Okay. So tell me if there's any other question.
Um, from 10B, I needed help on the first one was, hold up. Oh yeah, it was number 17.
Okay. One of the following numbers is not divisible, that one, right?
Yeah.
One of the following numbers numbers is not divisible. Not divisible by any prime number less than 10. By any prime less than 10. And the options are 2 power 606 minus 1. 2 power 606 plus 1. Yeah, 607 minus 1 also similarly. One last one is 3. 2 power 607. Okay. These are your options.
Yeah.
2 power 606. 7 plus 3 power 607. Okay. So first of all, you should know x power 2n plus 1 plus y power 2n plus 1 is divisible by x plus y. I have shown you this identity before or told you about it definitely, I remember. If you
Yes,
have
yeah.
odd powers on x and y, it is divisible by x plus y, right? So notice here, this is odd powers, no?
Yeah.
So x power this plus y power this is divisible by 2 plus 3, 5. Correct? So automatically E option is wrong, right?
You right. Yeah.
Do you understand what I'm saying right now?
Yes.
Okay. Then let's look at A option, for example, and let's look at prime numbers and all. So if you think of A option, it is not odd, it is not even, so it is going to be not divisible by 2. None of these numbers are even, by the way, right? So we
Yeah.
don't have to worry about 2 at all, right? We have to worry about
Right.
3, 5, 7, right?
Yes.
So here, if you do modulo 3 in the A option, so 2 can be written as minus 1 modulo 3, right? Correct?
Yes.
So this is going to be a plus 1 minus 1. It is divisible by 3, no?
Right. Yeah.
Do you understand why I'm saying?
Yes, I understand.
Similarly here, if you check by 3, it will be simply, you have to check it in a similar way. Uh, you have to check 2 power 606 plus 1. Check with modulo 3, right? then modulo 5 and so on, right?
Yeah.
So modulo 3, if you check, it is 2 is going to be 2 modulo 3 only, or but we can write it as -1, right? Modulo 3. Do you understand what I'm saying?
Yes.
But this becomes +1, so it is going to remain as +2 modulo 3 only, right?
Yeah.
But that means it is not divisible by 3, correct?
Right.
It is clearly not divisible by 3, no? It's obvious from there.
Yeah.
Now, if you want to check with 5, you can do 2 squared to the power 303. There are 4, so you can write it as 5 minus 1 to the power 303 plus 1. Right?
Yeah.
Again, the only term that you care about are the second last and last terms. Last term actually, which doesn't have a 5, right?
Yeah.
This is a binomial expansion with 304 terms. The only term that doesn't have a 5 in it is, like, if you see here, what is coming? All the terms in the binomial expansion have 1 5 at least, except last term, right?
Yeah.
So that last term, if you see, it will be 303C 303, 5 to the power 0 minus 1 power 303, right? This is 1, this is -1 plus 1. So it is divisible by 5. Oh, it is divisible by 5, yeah. We did 5. How did I start off by doing 5? I wrote it as a 4 power 303. Do you understand what I'm saying right now?
Yeah, I understand.
So similarly, you can do the other options also. You can check modulo 5, modulo 3, modulo 7. That's what you have to check. If you want to
Okay.
check
Yeah.
modulo 7, what I would do is try to group is at powers of 8 and all, right? Do you understand what I'm saying right now?
Yeah.
So we'll do it like this. This is 8, right?
Mm-hmm.
Notice that the total power is 607 now.
Yeah.
So you're
Oh,
getting
yeah.
2 into 8 to the power 202, right?
Yeah.
And this can be written as 1 plus 7 to the power 202.
Right.
So you automatically know every term other than first term will be divisible by 7. So
Yes.
only first term matters. So that is simply 1. And so 2 into 1 comes when you divide this purely by 7. Right?
Yes.
So what you have to do is go through the options. E was anyway eliminated by simple identity. It will be
Yeah.
divisible by x plus y. But other options you have to do modulo and think about whether you can divide them or not. Right?
Okay. Yeah.
And one of them will not fit and one of them will be answered. Right?
Yes.
Don't skip any question in this AMCs. Like when you are practicing at home, try to see every question and try to see till where, like so far it feels like 17, 18 is the point after which you get stuck. Right?
Yeah.
If questions before that are being are you are able to do them, then obviously our aim is to not get stuck on 17, 18, maybe push it to 20, 21, right?
Yeah. Okay. Yeah.
So you should definitely try seriously all the 17 to 25 questions because
Yes.
before that seems to be okay for you. So after
Yes.
that is what you need to work on.
Okay.
So any paper that you have, and there are many all the online papers you can find every year's paper actually. So
Yeah.
you should just go to 2024, 2023, and so on and do the 17 to 25 section, 16 to 25, something like that.
Yep.
That will help you know, okay, this is my level, these are the topics I need more work on. Okay.
Yeah.
Next class will be number theory. So we'll continue and we learn about Euclid's algorithm and stuff. So we'll continue from that point there. Okay.
Yeah.
But keep practicing more papers and focus your attention. You don't have to do the first 10, 15 if you are all the time you're seeing that you're able to do them.
Okay. Yeah.
You can just go through them once and see if there is anything that is particularly difficult. Those you can try, but target should be
Okay.
16 onwards, everything.
Yes.
Okay, we'll continue in the next class then.
All right. Wait, is the
Mm.
next class going to be number theory or AMC papers?
Next class is number 3.
Okay. All right. Thank you.
Bye.
Bye.